Alright, we're going to try another free response here. This time we have a graph, and it's a piecewise function, looks like, and it's talking about, it's giving us the acceleration, and with time from, looks like from 0 to 18 seconds, and they give us some information. So let's read through the first part of it. It says that, scoot over just a little bit. It says, starts off at time equals 0. It's going 55 feet per second. And so we know that, we know that v of 0 is equal to 55, and it's positive, so it's moving to the right. And then it looks like the acceleration starts off in a decreasing fashion, and acceleration is equal to 0 at 6 seconds. So just kind of look at the graph before you dive into the problem, and then it flattens out at this section right here, and then it starts to increase its velocity, its acceleration, and acceleration becomes positive at 16 seconds until the end of the graph at 18. So let's see if we can make some sense out of this. Alright, part A says, is the velocity of the car increasing at t equals 2 seconds? So at t equals 2 seconds, what do we know? We know that the acceleration is positive there, and the velocity started off at 55, and if the acceleration, even though it's a constant acceleration, it's still speeding up, right? So the velocity is increasing, so we can just simply say the velocity is increasing at t equals 2 seconds because the acceleration is greater than 0 at t equals 2 seconds. So that's pretty straightforward. And let's take a look at part B. It says, at what time interval between 0 and 18 other than t equals 0 is the velocity of the car 55 feet per second? So, well, let's see. Let's talk about what exactly is happening if we look at the area underneath the curve. So let's take a look at just a simple area formula. Not to break it down too simple, but area is, however we split this up, it's, if we do rectangles, it'd be length times width. If we split it up in trapezoids, it's half base 1 plus base 2 times the height, right? Well, the whole point of me talking about this is that I wanted to examine the units. So my base is going to be in seconds, and my height is this axis, and that's in feet per second squared, right? So if I just examine the units, second squared gets knocked down to seconds, and the seconds is canceled out there, and so the area underneath this curve is feet per second. Area is feet per second, which will tell you that that's equal to the velocity. And then another way to analyze this is to just think about PVA. If we go down, we're taking the derivatives, and if we're going up from A to P, we're taking the integral with respect to time, right? So these are very important concepts, and they test you on them quite frequently. So just having that basic concept will get you out of a lot of sticky situations. So let's take a look at a strategy to answer B. So if I start off, and if I'm traveling at 55 miles an hour and I'm still positive right here, I'm increasing, and I keep increasing. Now my rate of increase is still, it's going down, but I'm still increasing my speed, right? And then maybe, let's say when I get to 6, I'm at 150 feet per second. And I have no idea if that's accurate or not, but once I cross this barrier over into the negative world, my acceleration is, going negative, so that means my velocity at 150, which is where I was when I crossed, hypothetically, is now starting to decrease. Maybe I get back down to, 40 feet per second here. I don't even know, but just sort of trying to talk you through this. And then I'm going to remain constant at 40 right there, right? And then I start my increase. And I'm actually still slowing down, but my rate of slowing down is getting smaller and smaller. And let's say perhaps I end up at maybe I'm going -10 at that point. And then finally, once I cross back into the positive, my acceleration is increasing. Therefore, my velocity is probably going to go back up to positive something or the other. But anyways, let's see if we can just figure out this little problem. So now that we have that little concept map in our head, let's actually figure out some numbers here. So let me write this down. The velocity is equal to the integral from 0 to whatever time I'm interested in of the acceleration with respect to time, like so. So let's just say I want to split this graph up into a couple pieces. I want to look at this part of the graph right here and examine this area right here. So what do I know about the integral? I know that v of t minus v of 0 is equal to this integral, right? I mean, that's what you do when you take the integral. You find the antiderivative, you plug in the t value, you subtract the bottom number, which is 0 in this case, but we already know that this value right here is equal to 55. So it's minus 55, right? So if I add it to the other side, my velocity at any time along this curve is going to be my initial velocity plus whatever area I accumulate. So in the first example, we're going to go from 0 to 6. And let's see what we have there. Well, that's a trapezoid, and I'm going to use this as my base, and this is my base right here. So, and the height would be 15. So the area of that would be, I'll just do it over here, 1/2 6 plus 2 times 15. So that's 8. Half of 8 is 4, and that's equal to 60. So at 6, I'm at 60 plus 55, or 115. So this is my velocity at 6. Okay, so then let's take a look at the next little break in the action here. Let's split it up to right here. And that would just be a triangle. And the area of this is 1/2. From 6 to 10 is 4. And the height of that is 15. So I have, and of course it's negative 15. It's a negative area, right? So we have negative 60, half of that is negative 30. So if I want to look at the velocity at 12 seconds, no, 10 seconds, sorry. At 10 seconds, it's equal to the integral from 6, let me write that again, 6 to 10 of the acceleration. And we already know what 6 is, right? So the velocity at 10, similar to the problem before, it's going to be 115 plus this integral. So let's figure that out, which is negative 30. So you can just write negative 30 right here. So 115 minus 30. This is, I believe this was a calculator question, so this velocity is equal to 85. And we're looking to see where it's equal to 15. So let's consider this second area. Let's see if it, see about this point right here. So now we're going to look at sort of this area right here. And it may be too much. Well, let's just see. Let's do a little just geometry work right here. Between 10 and 14, that's 4 times 15. It's not a triangle, it's just a rectangle. So that's equal to 60. So 85 minus 60 would leave us 25. That's too much. So let's try splitting that in the middle. Let's go to there. So now it's, instead of 4, it would still be a height of 15, but now it's 2. 2 times 15 equals 30. And of course that's a negative as well, right? Because it's a negative area right here. So that would be 85 minus 30 would give me my 55. So the last thing we would say is that b of 12 is equal to the integral of from 10 to 12 of the acceleration. And we can go ahead and put that that's 85 plus that, right? Because that's the value at 10 that we just evaluated right here. So we can say that the velocity equals 55 feet per second at time equals 12 seconds. And we've got all our work justified over here to the right, so we should be okay. And just to clean it up here, this last step would be, would be 85 minus our 30 equals 55, and that's b of 12. Well, let's see what's happening in the rest of the term here. So let's just double check and make sure that we never equal 55 again, because it's possible that we might. So what's happening the rest of the curve here? We know that it's 55 here again, right, at 12. And so we could calculate this area right here and subtract it from 55. That's another trapezoid with a from 12 to 14. That's the base of 2, and then a base of 12 to 16 is 4. So we have half of, well, that's the same half as this other one, right, that we found a minute ago, of 60. Let's just double check our math here. We have 12 to 14 is a base of 2, and from 12 to 16 is a base of 4. Half of that, and we know the height is 15, so 6 and 3, 15. That's actually 45, isn't it? So it's a negative 45. 4 plus 2, 6, 3, 15, 45. Okay, so when we get to 16 seconds, the velocity at 16 seconds is equal to 55 minus 45, which equals 10. And then we can just go check the endpoint, which I'm pretty sure it's not going to make it back up there, but the velocity at 18 seconds is equal to 10. Let's see what we're looking at here. We're looking at this area right here. Just a triangle, right? So that would be a width of 2 and a height of 15. So that's a positive 30, right? Divided by 2. So it only increases by another 15. So it never reaches back up to 55 plus 15. So anyway, we might need that later on, but that's a good justification for part B. Alright, so now, well, actually we did a lot of the legwork for part C, right? Because we just found the velocities all the way across. So what is our maximum velocity? If we just go back, if we label all our work properly, we can just, probably just copy it again for part 2. Looks like we started off, and I think that we have a max velocity at 6 seconds of 115. Started off at 55. Our endpoint was 25. And if we use sign analysis, we could look at it and say the acceleration goes from positive to negative. Let's look at the acceleration right here. Acceleration starts off, and we're only going from 0 to 18. And it crosses at 6, the x-axis right here, and it crosses again here, so it's positive in this integral, this area, and it's negative here until we get to 16, and then it becomes positive again. So our candidates are at 6 and the endpoints, right? Because this here at 16 is a relative minimum, at 6 is a relative max. So we check the relative max, and we find out that it's 115. It's 0. The velocity is 55, and then we already calculated the end. So we're doing pretty good on that. And part D, when does it equal 0? Well, we've already looked at it, and we've already seen that it never is equal to 0 because we calculated the whole thing. So I suppose that we could just show our steps that we did again on part C and probably get credit for that. But anyway, hopefully this helps a little bit, and we'll try to make another one soon.